Now let's look into the most important testing, that is hypothesis testing. So hypothesis test, also called significance test. Hypothesis testing is also called as significance testing, are ubiquitous in the traditional statistical analysis of a published research. Their purpose is to help you learn whether random chance might be responsible for an observed effect. So, an A/B test that we have discussed before is typically constructed with a hypothesis in mind. For example, the hypothesis might be the price B produces higher profit. That's it. That's what we did. The hypothesis might be that price B produces higher profit. Why do we need a hypothesis? That's the question. Why not just look at outcome of the experiment and go with whichever treatment does better? So the answer lies in the tendency of the human mind to understand the scope of natural random behavior. So one manifestation of this is the failure to anticipate extreme events, or so-called black swans. Another manifestation is the tendency to misinterpret random events as having patterns of some significance. So statistical hypothesis testing was invented as a way to protect researchers from being fooled by random chance. Okay, so let me share how humans misinterpret randomness. Let me do that. Let me show you. So hypothesis testing. So misinterpreting randomness. That's what we will discuss now. So you can observe the human tendency to underestimate randomness in this experiment. So ask several friends. Your task is to ask several friends to invent a series. Just a minute, sorry. Invent a series of 50 coin flips on their own. Have them write down a series of random hits and tails. Then after that, that's the task 1. Then task 2 is to actually ask them to flip flip a coin 50 times and write down the results. Have them put the real coin flip results in one pile. And task 3, have them put the real coin flip results in one pile and the made up results in another. So it's easy to tell which results are real. The real ones will have longer runs of heads or tails. In a set of 50 real coin flips, it's not at all unusual to see 5 or 6 heads or tails in a row. So result would be in a it's in the real ones will have a longer runs. It's not at all unusual to see 5 or 6 heads or tails in a row. But when most of us are inventing random coin flips and we have gotten 3 or 4 heads in a row, we tell ourselves that for the series to look random, we had better switch to T. That's how the human mind works. That's how we are biased. So, the other side of this coin, so to speak, is that when we do see the real world equivalent of 6 heads in a row, example, when one headline outperforms another by 10 percentage, we are inclined to attribute it to something real, not just to chance. So that's the reason. So we are not sure about the randomness. We misinterpret the randomness. That is the reason we use hypothesis testing. We use an hypothesis testing to check this one. So the purpose is to help you learn whether random chance might be responsible for an observed effect or not. That's the main purpose of hypothesis testing. So if you look into in a properly designed A/B test, you collect data on treatments A and B in such a way that any observed difference between A and B must be due to either. So, random chance in assignment of subjects, a true difference between A and B. So, a statistical hypothesis is further analysis of an A/B test. So, let me write down a, a statistical hypothesis test is further analysis of an A/B test or any randomized experiment. So to assess whether random chance, this is very important. Why we are doing hypothesis testing is to assess whether random chance is a reasonable explanation for the observed difference between groups A and groups B. So that's the main reason of doing hypothesis testing, that is to assess whether random chance is a reasonable explanation for the observed difference between groups A and groups B. Now let's get into the slide back. Now let's see. So now it's clear. I hope now it's clear for you what is hypothesis testing. Now let's look into the null hypothesis first. So hypothesis tests use the following logic. What is that? Given the human tendency to react to unusual but random behavior and interpret as something meaningful and real. So in our experiments, we will require a proof that the difference between groups is more extreme than what chance might reasonably produce. So this involves a baseline assumption. What it is? A baseline assumption that treatments are equivalent and any difference between the groups is due to chance. So this baseline assumption is termed the null hypothesis. So our hope then is what we can in fact prove the null hypothesis wrong and show that outcomes from group A and B are more different than what chance might produce. So that's what is a null hypothesis. And similarly, we will have an alternative hypothesis, which is a counterpart to the null hypothesis. So, an alternate hypothesis is nothing but a counterpart to the null hypothesis. There, what you hope to prove. That's what is a alternate hypothesis. So let me put the null hypothesis in much simpler way. In statistical hypothesis testing, the null hypothesis is a statement that there is no significant difference between two populations or variables. It is usually denoted by H naught, and it represents the default assumption that no relationship or effect exists between the variables being studied. So this kind of hypothesis is called null hypothesis. We will see some of the examples. I'll write down the null hypothesis example, then we will write down the alternate hypothesis for that. So null hypothesis is pretty simple. So it's nothing but so null hypothesis always involves a baseline assumption that either the treatments or groups are equivalent, and any difference between the groups is just due to chance. So this baseline assumption is termed null hypothesis, and our hope then is that we can in fact prove that null hypothesis is wrong, and show that the outcome for groups A and B are more different than the chance might produce. Okay, so that's what is null hypothesis. What we say simply is null hypothesis is nothing but whatever the difference is there, that's because of chance. In fact, there is no difference. You got it? We just blame the randomness. Because of that it's happening, but there is no actual difference. Now we have to prove it. No, there is actual difference. So some of the examples, let me write down here. First one is there is no significant difference in test mean test scores between male and female students too in a particular school. It could be any school, and the average salary of employees in a company is not affected by their years of experience. Third, there is no significant correlation. It's very important for a data scientist. Correlation between the amount of time spent exercising and the level of blood pressure in adults. Then fourth example for the null hypothesis, these are all null hypothesis. The proportion of defective products produced by a manufacturing process does not exceed a certain threshold. Then last example, the mean weight of apples grown on two different farms is not significantly different from each other. So these are some of the examples for null hypothesis. So In each of these examples, the null hypothesis assumes that there is no significant difference or relationship between variables being studied. The alternative hypothesis, on the other hand, represents the opposite of the null hypothesis and asserts that there is a significant difference or relationship between the variables by conducting statistical tests and analyzing the data, so researchers can determine whether the null hypothesis can be rejected or confirmed. So that's what is our null hypothesis. Now let's look into the alternative hypothesis quickly, and we'll come back for the respective examples. The alternative hypothesis tests by their nature involve not just a null hypothesis but also an offsetting alternative hypothesis. So here you can see some of the examples. Null, obviously null is nothing but no difference. Simple way. Null difference. So no difference between the means of group A and group B. Then alternative for this is A is different from B. Could be bigger or smaller. We are not sure. Okay, it could be bigger or it could be smaller. So that's where your two-way test and one-way test comes to decide whether it is bigger or smaller, or it's bigger and smaller, or it's both ways. To say both ways, whether it is only bigger one-sided, but either you can do one side test or you can do the both sides test, either only to check whether it is positive, or it check to negative whether it is greater or lesser, or you can check both ways. So null hypothesis, say A, this is one, A less than or equals to, this is one null hypothesis, and these are the hypotheses that we widely use. If uh, so this is one way, A greater than B is one way, so it could be bigger or smaller. So null hypothesis is A less than or is equals to B, then alternate is A greater than B. And null, B is not X percentage of greater than A. This is obviously in your proportion. Alternative is B is X percentage greater than A. So now let's convert null hypothesis of our examples into 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 alternate hypothesis. So alternate hypothesis is corresponding to the null hypothesis. Okay, so let me give examples. The mean test scores of male and female students in a particular school are significantly different. It's not same. Then 2, the average salary of employees in a company is affected by their years of experience. And third, there is significant correlation between the amount of time spent exercising and the level of blood pressure in adults. Then fourth alternative hypothesis, the proportion of defective products produced by a manufacturing process exceeds a certain threshold. The last one, the mean weight of apples grown on two different forms is significantly different from each other. So these are some of the examples for alternate hypothesis. This is represented with HA, and null hypothesis is H0. So let me put it here. And then this one HA. Okay, so now let's look into the more terminology from hypothesis testing. Next one we have is one-way and two-way hypothesis test. What is one-way hypothesis test and what is two-way hypothesis test? So one-way hypothesis test, also known as one-tailed test. One-tailed test. It's a statistical hypothesis test in which the alternative hypothesis specifies the direction of the effect being tested. In other words, the researcher is interested in whether a particular variable has a significant effect in a specific direction, either positive or negative. I have told you before while explaining this, either positive or negative. Let me put it in writing here. So next one we have is a one-way test. So one-way test is nothing but a researcher interested in whether a particular variable has a significant effect in a specific direction. It could be either positive or negative. So let's take one example. So suppose a researcher wants to test whether a new medication decreases the average blood pressure of patients. Okay, so that's what he wants to test, whether a new medication decreases the average blood pressure of patients. So for him, so null hypothesis is the null hypothesis would be that the medication has no effect on the blood pressure. The medication has no effect on the blood pressure. Now I want to go for alternate hypothesis, HA. So the alternate hypothesis would be that medication, see that medication decreases the blood pressure, and that's it. It's clearly one side, it's a negative side. We are saying decreases, one direction. If we say it may increase or it may decrease, it will increase or decrease, we are not sure, but something or it will happen. This or that will happen. In that case, that is alternate hypothesis is two-way. It's a two-way test. But here we are saying medication decreases the blood pressure. That means it is one-way test. So this is a one-way test. This is a one-way test because the alternate hypothesis specifies the direction of the effect decrease in blood pressure. One-way tests are often used when the researcher has a specific prediction or hypothesis about the direction of the effect based on previous research or theory. By using a one-way test, the researcher can increase the power of the test to detect significant effects in the prediction direction. However, it's important to know that using a one-way test also increases the risk of a type 1 error. What is type 1 error? We will be discussing, not to worry, but for now, type 1 error is rejecting the null hypothesis when it is actually true. Rejecting the null hypothesis when it is actually true is called a type 1 error. So careful consideration should be given the choice of test and the directionality of the hypothesis. Now, two-way test. So two-way test, also known as a two-tailed test, is a statistical hypothesis test in which the alternate hypothesis does not specify the direction. That's it. If you don't specify the direction, that's a two-way test. So that effect being tested. In other words, the researcher, let me put it here, two-way test. A researcher is interested in whether a particular variable has a significant effect regardless of whether the effect is positive or negative, regardless of whether the effect is positive or negative. Okay, so let's take one example. Suppose a researcher wants to test whether a new advertising campaign increase the average sales of a product. So null hypothesis is null hypothesis would be that the advertising campaign has no effect on sales. And alternate hypothesis is that the advertising campaign has significant effect on sales. So either positive or negative. So this is a two-way test because the alternate hypothesis does not specify the direction of the test. So okay, so the two-way tests are often used when the researcher does not have a specific prediction or a hypothesis about the direction of the effect, or when the directionality of the effect is not important. By using a two-way test, the researcher can detect a significant effects in either direction and can be confident that the results are not biased by preconceived notions or explanations about the direction of the effect. So now it's time to see one-way test versus two-way tests. Often in an A/B test, you are testing a new option, say B, against an established default option A, and the presumption is that you will stick with the default option unless the new option proves itself definitively better. In such a case, you want a hypothesis test to protect you from being fooled by chance in the direction favoring B. So you don't care about being fooled by chance in the other direction, because you would be sticking with A unless B proves definitely better. So you want a directional alternative hypothesis. That's B is better than A. That's what we want. So we want a directional alternate hypothesis. So B is better than A. In such a case, you use a one-way test, a one-tail test, a hypothetical test. So this means that extreme chance results in only one direction count towards the p-value. So if you want on other way, if you want a hypothesis test to protect you from being fooled by chance in either direction, the alternative hypothesis is bidirectional. A is different from B. It could be bigger or smaller. You don't worry. You don't need to worry about that. You don't care about that. In that case, we will go for the bidirectional. In such a case, we use a two-way hypothesis, or we can call it as a two-tail hypothesis. So this means that the extreme chance results in either direction count towards p-value, either in both direction, left or right. In that case, we'll go for the two-way test.